Resume recording. Okay. Day one, matrices and their inverses. So when we talk about inverses, something important when we talk about an inverse of a matrix. For it to have an inverse, it has to be a square matrix. So again, we're talking about our 2x2s, our 3x3s, 4x4s. So similar to when we talked about finding the determinant, in order to find the determinant, it has to be a square matrix. In order to find an inverse, it has to be a square matrix. Now, just because it's a square matrix doesn't automatically mean it has an inverse. So something to think about. We talk about an inverse. What is an inverse? An inverse, so when we talk about addition, an inverse is something where I do that operation and I end up with what we would call the identity or itself. So when we talk about, well, let me go ahead and show you with what I'm talking about with our matrices. So this is going to be what we call the multiplicative inverse, which means we're going to be multiplying. So the product of a matrix and its inverse is equal to the identity matrix. For instance, if I have some matrix A and I multiply it by its inverse, remember inverse notation is to that -1. It's not saying take the reciprocal. So this is just using inverse notation, is equal to the inverse times the matrix. So this is what we call commutative. So we could switch them around. So it's commutative would be equal to our I, and that I stands for our identity matrix. So if we're going to talk about real numbers, so if I have something like 2 times the inverse of 2 would be my 1/2, I would get my value of 1. That's the identity matrix, because if I multiply this by either one of those, I end up with itself. So if I take my identity matrix and multiply it to either one of these, I end up with itself. So this would be the inverse for multiplication. For addition, if I have something like 2 plus, and my inverse would be a -2, and I would have a value of 0. Now notice, if I add 0 to either one of those, I end up with itself, different than multiplication. So it's whatever I can do with this operation that it equals makes it that identity value. So this is for addition, multiplication, and this is now applying it to a matrix. Okay, I told you, I highlighted it here. I'm going to tell you again, we must be using square matrices. So must be square, must be square. If it is not square, don't even bother trying to do it. You cannot do it if it is not square. I told you that not every square matrix has an inverse. And when it doesn't have an inverse, we call that a singular matrix. It means it only has itself. It's just itself. You cannot do anything with it. So that square matrix does not have an inverse. We call it a singular matrix. So if it does not have a inverse, we call it a singular matrix. And the easiest way to see if a matrix is singular or not is by figuring out the determinant, So if the determinant is equal to 0, then the inverse does not exist. If your determinant is equal to 0, the inverse does not exist. Remember notation, this would be the same thing as those two straight lines. If it curves in, it's talking about the matrix itself. If they have the little bracket pieces, if they're just straight, it's determinant. So if it's equal to 0. As a little bit of a review, I'm only going to do it for the 2x2. So if we want to figure out the determinant of A, B, C, D, then if you recall, the determinant of this matrix, the determinant of A notation, straight lines A, B, C, D, is equal to, I multiply my diagonals, A, D, minus, I multiply my diagonals, C, B. So just a little bit of a review there on determinant. So determinant equals 0. There is no inverse. You can't find it. If it equals some value other than 0, there's an inverse. So let's go through this first piece. This is which of the following matrices do not have an inverse? So the easiest way to figure this out is what is the determinant? So figure out the determinant of each. So we want to figure out the determinant of each. All right, so let's go ahead and do that. So this would be 3 times 3 is 9 minus my 4 times 1, which is 4, and I end up with the value of 5. So does this have an inverse? Yes, because this is a value other than 0. It does not have an inverse when the determinant is equal to 0. So if we want does not, we want the determinant to equal 0. For does not, we want the determinant to equal 0. So let's do our next one. So 3 times 3 is 9 minus 3 times a negative 3 is a negative 9. So this is going to give me 9 plus 9, which is 18. Watch your signs, because if you messed up your signs there, you would most likely get it wrong. So again, this isn't equal 0, which means it has an inverse. As long as it's not 0, it has an inverse. If the determinant is 0, then it does not have an inverse. So let's go to my next one. 0 times 2 is 0, minus 0 times 1, which is 0, is 0. This means it does not have an inverse. The determinant is 0, so there is no inverse. If it asks you to find the inverse, you would say not possible, does not exist. There is no inverse. And lastly, we have our 1 times 2 is 2, minus a negative 2 times a negative 1 is going to give me a positive 2. So it's 2 minus 2 is 0. Again, this means that there is no inverse for that matrix. It does not exist. So for figuring out if an inverse exists or not, you need to find the determinant. So building on our prior knowledge. Okay, well, what if an inverse does exist? What would we do with it? How would we do that? So notice we're focusing a lot on the 2 by 2s. That's going to be the primary ones we're going to be working with. It doesn't mean that there aren't going to be 3 by 3s, but I'll get to that in a second. But primarily it's going to be 2 by 2s. All righty. So what if I have a 2 by 2 matrix? So here's my matrix, and I want the inverse of it. And I want the inverse. To figure out the inverse of this matrix, to figure out the inverse of that matrix, it's 1 over that notation. Remember, it's the straight lines of matrix A. So it's the determinant of my matrix A. So it's 1 over this determinant of this value here. And then my C and B are in the same spots. C and B are in the same spots. I just need to take the opposite sign of them. And A and D switch locations. So A and D switch locations. This right here would give me my inverse. Kind of a lot to take in when you look at it, but this is what we're going to be looking for. This is going to be what we're going to do with our problem here. Okay, so let's look at this. Let's piece it together. To figure out the inverse of this matrix, my A inverse, it's equal to 1 over the determinant of A. Okay, so I need to figure out this determinant. So the determinant of 4, 2, 3, 2 is going to be, I need to figure out that determinant. So it's 4 times 2, which is going to be 8, minus 3 times 2, which is going to be my 6. So the determinant is 2. So this value here, this determinant, this value here is going to be 2. Okay. Then inside my matrix. A and D switch locations. So A and D, these two are going to switch locations. So this becomes a 2 here and a 4 here. My 3 and 2 stay in the same spots. My 3 and 2 stay in the same spot. Oops. But I switched the signs. So these are both positive. So I'm going to switch the signs and make them both now negative. Now, if one of them would have been a negative, it would have become positive. It's always the opposite signs. So same spots for this, same spots for this diagonal. So 2 and 3 in the same spots, but I switched signs. This is now just a scalar. That means you just multiply through to each piece. So that's going to be 1/2. So I could simplify this, and it's just going to be 1/2 of each one of these numbers. 1/2 of each one. So 1/2 of 2 is going to be 1. 1/2 of -2 is -1. 1/2 of -3 is -3/2. And 1/2 of 4 is 2. This right here is going to be our inverse of my matrix A, is this piece right here. These are inverses of each other. What does that mean? It means if I multiply these together, it would equal my identity matrix. And what is that identity matrix? So if I multiply A times my inverse, or my inverse times A, it would equal that identity. And for a 2 by 2, that would be my 1, 0, 0, 1. And we could check this out. Let's see if I have this handy. So let's look at this. So I have a 2 by 2. My matrix A is going to be my 4, 2, 3, 2. Okay, so my B is going to be my inverse one. I can't put it in, change that to show the inverse there, but I'm going to use it as my inverse. And I'm going to do 1.5 just because that's easier to put in instead of 3/2 and 2. So what happens when I multiply my A times my B? There's my identity matrix. What if I switch it? What if I do my B times my A? There's my identity matrix. Are you guys able to see the calculator? Did I set it up correctly? Cool. So you can see that no matter which way I do it, I'm ending up with that identity matrix. Any questions on that? So this is definitely a new concept. Follow it here. Just kind of match up the letters on what you guys are doing. It's the same every time for when you guys are doing these 2 by 2s. All right, then my last example. So my 2 by 2s are always going to be done this way. For my last example, my 3 by 3. For this, you need to use the matrix calculator. They're not showing you another way to do it, but using the calculator. Easy enough, right? So all I need to do is plug this into my calculator. And then we'll go ahead and we'll hit our button. So let's see, what's it gonna look like? So I'm gonna go here, I'm gonna change this to a 3 by 3. Okay, and so it gave me that error because I have them being multiplied and it's saying it can't be multiplied because that operation is set to multiplication. So I'm just gonna ignore that because I'm not gonna even worry about multiplying them. So oops. So I have 2. Let me just change that so it's not gonna keep giving me, there we go. So I have 2, 3, 3, 3, 1, 2, and then 7, 8, 9. So if I want to figure out what is going to be the inverse of this, then I go to inverse of A, and there's my answer. So the inverse of this is going to be, I'll write it right down here. I'm going to copy that down. It's going to be 3.5, 1.5, negative 1.5, 6.5, 1.5, negative 2.5, negative 8.5, negative 2.5, and my 3.5. So you'll be asked to figure that out. And then your answers might be something like, what is A or what is E or whatever they might be. So just remember that this would be your A, B, C value. They correlate positions. This would be your D, E, F, G, H, and I. And just like the 2 by 2, if I multiply my A times my inverse for the 3 by 3, it would be the inverse times A, which is going to be my identity. So for my 3 by 3, that identity is a 1, 0, 0, 0, 1, 0, 0, 0, 1. So if I put these two together in there and I multiplied them, I would end up with this matrix. And of course, you could test it out. That's all I have for you guys today. Tomorrow, they have these coding ones, and I don't feel like they explain them very well. So I do have examples to talk about the coding and how to decode stuff. So if you move on to the next assignment, again, I don't think they explain it very well in the notes portion, but I do plan on touching base on that tomorrow as you guys go through the assignments. It definitely shows up there. Otherwise, you guys have a blessed day, and I will see you guys tomorrow. If you guys have any questions, let me know. Bye, you're welcome.